So today, or now, we will talk about the left-hand rules. In total, there are 3 rules that we will discuss. And before we move to what are the rules and how can we apply them, I just want to clarify that when we are talking about the current, the direction of the current, or the conventional current, what we are identifying is the direction of the positive charge. And when we are talking about electron flow or electron current, then what we are saying is, what we are defining is the direction of negative charges. Let's talk now about the rules. So the first left-hand rule creates a connection between the direction of magnetic field and direction of the charges. Positive or negative doesn't matter, but they are moving in a straight line. So the first rule is saying that the thumb is telling us what is the direction of the negative charge or the electron. Of electron flow. And fingers curling around the direction of the electron flow are telling us the direction of magnetic field strength. So see what we are saying here. If we have an electron current or an electron flow moving into a straight line in this direction, then the thumb will be up, and then the fingers will coil will hug the coil or the direction of the electron flow into this way. So this will be the direction of the magnetic field that the electrons are creating. Okay, or if we have the electrons moving in a straight current going east, then the thumb will be going east, and the fingers will hug, will coil, will curl around current or the direction of the electron going, and the upper part going up, and then in going like this. This is V. Okay. Or if we have the direction of the electron that is into the field, this sign here. So imagine that you have a current and you have a current that is going into the field, and the electron current is going into the field. So this is the electron. Then the thumb will go into the field, and the fingers will coil the current, and will be something like this. Okay, because as we said the other day, magnetic field has continuous lines. So that is telling you that if you place a compass here at this point, then the north will be on this direction. If you place the compass here at this point, then the north of the compass will be in this direction, and so on and so forth. So this will be the direction of the magnetic field created by the charge. Now you may ask, what if the charge is positive? So what will happen on this case? I know that I said that I will deal with it at the very end, but in terms of the right-hand rule, but let's do it as the rules are explained to you. So on that case, what will happen are two things. One of the two things, if I'm telling you that the direction of the conventional current is, let's say, out of the field, so this one here is a positive one. Direction of the current is out of the paper. Then the finger, if you are using the left-hand rule, then you will switch the direction. So you will say, what is this? Is the direction of it. I means the direction of positive charges. Since I'm using the left-hand rule, then I will switch the direction. So from out of the page, I will make it into the page, and then the magnetic field that is created will, the direction of magnetic field will be given by your fingers coiling the wire. So magnetic field will be like this. This is one way. What you can do is you can use the right hand. So when you're using the right hand, you're saving the direction. So we said that we have a positive charge that is coming out of the page. How do we know that it's positive? Because they are giving us the direction of the conventional current. So it's out of the page. Now with your right hand, you will save the direction, and then you will coil the direction. So then you will have a magnetic field that is of this direction. And those will be concentric circles that are created around the direction of the motion of the charge, that being positive or negative. So I would say let's stick with the left-hand rule and not mess up with the right-hand rule, because left-hand rule, it's just, if it is positive, you switch it. If it is negative, you save it. Okay, and especially for students that are right-handed, then it's good to use the left hand because they define the direction with the left hand that is not their dominant hand, and then they just write the answer for that question. Okay. So now let's suppose that we have a wire, conducting wire, and the electrons are moving from A to B. And here on top of the wire, what we are doing is we are placing a compass. Now we will see in which direction the compass will head. So what is the direction of the north of the compass? Now the electrons are going down, so then the thumb will be down. We don't change the direction because the electrons are negatively charged, and then the fingers will wrap the current, and on this way what we will see is that the current or the magnetic field strength will be on the right of the wire, will be going into the page, and on the left of the wire will be out of the page. So we'll have something like this. So notice here the convention that we are using. So we are making it as a 3D. Left, right, up, down, and then into the page, and a dot is out of the page. Okay, so we are moving on 3D here. So now what does that means is that the compass will be toward north. Okay, so we'll be heading toward north, so the compass will be up. But if we take now and we have a compass that is going down, so if we place the compass down, when the compass is placed down, or under the wire, then direction of compass will be going this way. So north will be going this way. Okay. So let's do some more examples. Let's say that we have the direction of the electron is this one, then the magnetic field strength will be this way. So because the fingers will be going on the upper part into the page and on the lower part away from the page or out of the page. The way that we are presented with a left, right, up, down, in, out of the page will be the electrons are moving this direction. So on the top part of the wire, since it is going into the page, will be this convention, and on the bottom part of the wire will be out of the page. So this will be magnetic field strength. However, if we have the electrons, let's make electrons going in this way, then thumb will go down and fingers on the right of the wire will be into the page, and in the left, on the left of it, will be out of the page. But if we have a proton or the positive charge, then we will switch the direction. So now the thumb will be up and the magnetic field on the right of the wire will be out of the page. And in the on the left of the wire will be into the page. therefore, if we have protons or intensity of the current coming out of the page, then you will switch the direction if you're using left-hand rule. So you will go into the page, and then magnetic field will be circle because they are continuous lines. So, and will be on the search. So if you place the magnet here, then will be on the right will be in north will be into the page or compass here, and on the left will be out of the page. And if you place a magnet here, will go on the north of the wire will go to west, and the west of the wire will go to south. In the south of the wire will go to east, and in the east of wire will go to north. So just keep in mind that what we are dealing here is the charge moving into a straight line, and this is the first left-hand rule. So you have to know the relationship between the direction of the charge and the direction of the magnetic field that the charge is creating. Now, if you know that the charge is moving into a straight line, you don't know. So this is what it is. And then you see that the magnetic field is on the top part is into the page, and on the bottom part is out of the page. And then you are asked for the direction of the electron. So then you will see it going up is, so fingers will go up into the page and down away, like out of the page. So the fingers will be into the page up and out of the page down, which tells you that the direction of the electron is east. So if they are asking for the direction of the electron current, but if you have a situation that, let's make it a different one. If you have a situation that they are saying that the current is going up and down, you don't know which one, the current, the conventional current, and then you have the magnetic field that is on the left is into the page, sorry, on the right is into the page, and on the left is out of the page. This, then you will move fingers in that direction. So on the right of the wire, you will make them go into the page, and on the left will be out of the page, which tells you that the direction of the electron is the direction of your thumb. And if I'm asking for the direction of the current, intensity of the current, or the conventional current, or the positive charge, then you will switch it. Okay, so first rule gives us the relationship between the direction of the charge moving in straight line and the direction of the magnetic field created by those lines. Okay, so this is the first left-hand rule, and I will stop the video here so that I will have the second rule on another page, and the third on another video, and the third rule on another video. Okay, so that it's not too overwhelming.